scenario. A cart is pressed up against a spring that is attached to a wall such that there is a value US, which stands for the spring potential energy. When let go, the cart travels on a frictionless surface, then up a ramp. The cart reaches a height of h0. The student wants to repeat the experiment with some modifications. The new height is labeled h1. Question: how will h0 compare to h1 when the spring is compressed more? Answer: the h1 is going to be greater than h0, so that new height with this modification is higher than before. Why? Well, the spring compressing more will mean that there is going to be an increase in the spring's potential energy. More spring potential energy at the start means more energy is going to be transferred to the gravitational potential as it goes up the ramp. More gravitational potential means there is going to be a greater height value. Next question: how will h0 compare to h1 when the ramp's incline angle theta decreases? Well, the answer: h1 is equal to h0. The new height is going to be the same height as before. Why? Well, theta has no effect on the energy transfer between the spring potential and the gravitational potential. Theta will affect how high the ramp can go, but does not affect how high the cart can go on that ramp. Last question: what can the student do so that h1 is actually less than h0? That means the final height is actually lower than the initial height. Well, the only way to achieve this is to look at the force. Please note that a force exerted on an object can change the kinetic energy of the object. The only force here is actually that spring force. So the spring force has to decrease somehow. Once the spring force decreases, then your new height can be less than your original height.